Hi, welcome to another edition of Fun with Conceptual Physics, the Momentum Edition. So up here you're to write the equation for momentum. Momentum is a symbol P equals m times v, and v is velocity. This v is velocity, and one thing about velocity as opposed to speed, it has direction. This is a vector, so I'm going to put a little hat on top of it. Some people use arrows, but since velocity has direction, so in other words, if an object is moving in this direction with a velocity, the momentum has to be in the same direction. So momentum has direction, so it is a vector. That's highly important you remember that. This is what is the momentum to these two objects? Well, since it has direction, and we know momentum is mass times velocity, 3 times 4 is 12, and the units are, you write down what you see, kilograms, meters per second, and it will be to the right. This is 6 times 2. Notice this arrow for 4 is very big, and this arrow for 2 is very small, because it's half the size of that. But 6 times 2 is also 12 kilograms meters per second, but it is to the left. What is different about these two objects? The direction of the momentum. They're both 12, but one is to the right, one is to the left. Next, I'm assuming you wrote that down. If velocity is tripled, what will happen to momentum? Well, if I write P equals m space v, if I triple my velocity, I have to triple my momentum. P will triple. So if you're going faster, you'll have more momentum. If velocity increases, momentum increases. By the same amount. So wait a second or two. Next, if the momentum of the airplane increases. So now they're saying, if you notice here, these arrows are in here for a reason. This arrow was to say velocity is going to increase. So what happens to momentum? Here, you know momentum is going to increase. If mass remains constant, then velocity must increase. So if this doesn't change, that has to. I'm telling you, your momentum's going to increase. Suddenly, you're going to have more momentum. Why? Because you had to have sped up, speed up, one or the other. These next two are very important. What causes an object to change momentum? An impulse. Not a force, but an impulse. a force and a time. So impulse, I'll write it here, equals force times time. That changes momentum. Another word for force is called impact. You'll see that on the quiz. Impact means force. Please draw that arrow and remember that. An impulse is what changes momentum. So I'll leave this up for a second. An impulse is force times time. A force by itself is called an impact. A force is another word for impact, or impact's another word for force. They're interchangeable. And this is what causes a change in momentum, an impulse. So at this point, I'm hoping you've kept up. I'm going to move to the back side of this. This should be pretty easy. Which has more momentum? Well, momentum is mass times velocity. Anything standing has zero velocity, which means its momentum is zero. Therefore, a small dog pulling a wagon is moving. So this does have some velocity. It's some number. Even though you're large, if you're standing, you have no momentum. Here's another one. A very fast squirrel. It might be fast, but if it's sitting, it has a zero velocity. So it has no momentum. A slow turtle has more momentum than a fast squirrel sitting. That should make sense. So a turtle. Here, you're on a bird on a roof getting ready to fly. If you're getting ready to fly, have you taken off yet? No. So you can assume the bird has zero velocity. A deer standing has zero velocity. So they have the same zero momentum. Neither one is bigger. So I'm not circling either one. It said circle the larger one. The momentum's the same. They're both zero. Next, it says write the equation for the impulse. Impulse equals force times time. What's another term for force? Impact. During any collision, your impulse is kind of set. It's constant. Here's a rule. If you increase time, force decreases. On the other hand, if you decrease time, force increases. And another word for force is impact. The impact will decrease or the impact will increase. Remember, impact is another word for force. Okay. Take your time and read this to yourself, this statement here. I'll give you a minute or two. So, what's car A going to run into? Yes, over there, in the dark hoodie, a haystack. What's car B going to run into? Over there with the red top. You, go ahead. Yes, a brick wall. Here's the rule. Haystacks are soft. Brick walls are hard. There's no other way to describe it. If you have a soft object you're going to hit, you have a big time to stop. It's going to take a long time to stop you with a soft object. Here, you're going to have a short, small time to stop. And what's the rule? Right up here. If you have a big time, you have a small f. If you have a small time, you have a big F. So, for question 15, for case A, you have a small force because you have a big time. For case B, you have a huge impact because you have a small time. So, soft objects have small times, hard objects have big, or soft objects have small forces, hard objects have big forces. So whoever has the larger impact force is the harder object, which is B. That should make sense. So go by the object. Hay is soft, so small force. Brick walls are hard, so big force. Now, as far as impulse, this is tricky. Believe it or not, even though one has a bigger force, they have the same impulse. How is that? Because they're both the same car, and they're both going to come to a stop from the same speed, so they have the same impulse. Just one hits a hard object, one hits a small object. So a small force and a big time is the same as a big force and a small time. We talked about that. They have the same impulse, but they have different forces. Different forces. So, there you go. I'll leave that up there for a second. It should make sense. Don't even make this a big deal. Just know if you hit a hard object, you're going to have a big force. You hit a soft object, small force. And even though they have different forces, they have the same impulse. That is a guarantee. That's because of the trade-off. With a small force, you have a big time. Big force, small time. If anybody needs an example, I can put some numbers on a board, but that's it.